All right. Now, I want to set expectations here. I'm very grateful you're all here, but this is not about sharing all my secrets. This is about seeking secrets, how to find the secrets. And it's going to be a really fast presentation because we're seeking, and my friend Ben said, it's a good thing you're not scanning. We're seeking. And Ben's right there, and he's my friend. I told him he wasn't when he made that joke. I called him my former friend, but I was just kidding. So, what are we going to look at? We're going to look at me. Here's me. And something I hadn't put on my my background slide before is my contacts, my website. A lot of you are familiar with. I do have a Facebook page for technical stuff. I try to just put personal stuff on my personal Facebook page. So if you've requested to be my friend and I've ignored you, it's because I just keep that for personal stuff. But I do have now a technical Facebook page called SQL Internals. That's the name of the URL for the page, but if you go to Facebook and you just search for SQL Server Internals, you'll find me. There's somebody else whose actual URL for their Facebook page, though, is SQL Server Internals. It's very confusing. But make sure it's my page. It's got a picture of the book as the avatar there. And then my blog site here. And I've heard from a number of people this week asking why I don't unprotect my tweets. And this is like a meaningless, moot question because I don't tweet. And in fact, some people have been trying to talk me into it. I do have a Twitter account, but I got that just so I could keep track of a person I was doing a project with, and he was always tweeting where he was, and I wanted to know why he wasn't working on the project. But I never... I said, how come I can't get a hold of you? And he goes, oh, I always put on Twitter where I am. So he told me to. So I got a Twitter account so I could follow him, but I've never tweeted. And I am leaning in that direction now. A lot of people have been trying to convince me to. So I will tell you that as soon as I do start really tweeting, then I will unprotect my tweets. So as long as it's saying you need permission, then I'm not really doing it, okay? So end of that story. So what we're going to look at today is several categories of secret information. We'll be looking at trace flags and DBCC commands, and I'll tell you some of the reasons why some of these have made their way into the product as undocumented features. We will look at other undocumented commands and talk a little about what exactly that means for something to be undocumented. But of course, in the meantime, I will be demoing some of my favorite undocumented commands so you can see how these things might come useful. And then I will be giving you some checklists of places for you to go and look to find undocumented secret information of your own. And the secret is in quotes for a reason there, because a lot of this information isn't truly secret. It might just be hard to find, or it might just be information that's been out there all along and just it isn't something you happen to look at. But before we actually start with the presentation itself, I would like to do a commercial here. I put this on my Facebook page and I announced it at my pre-con. A former student of mine is collecting donations for a mission project that he goes on to Nicaragua. And we had a box at the Redgate booth. If anyone brought anything in today, JT will be collecting stuff today. I brought a few things in, and someone else stopped some on. These are hotel toiletries. Any hotel amenities, any other toiletry items will be greatly appreciated, and I really appreciate what you're doing, JT. Thank you very much. All right, so those can be collected afterwards. Also, I have a couple of giveaways that I'm trying to figure out the best way to give them away at the end, and I'll tell you about them when we get to a particular place within the session today. So I'm going to talk about exactly what it means to be undocumented. I think I went over that. What's topics and agenda? Why do I have two different slides for that? I'm not sure. So what exactly does undocumented mean? And there's a couple of different definitions for it. Some people think undocumented just means it's not in the books online. In fact, Ken Henderson, who wrote the Guru's Guide books and puts a lot of undocumented stuff, or put past tense, a lot of undocumented stuff in the appendices and special chapters of his books, he basically defined undocumented as not in the books online. But it actually turns out that according to Microsoft, anything that's in a knowledge base article is really, they consider that documented. And because what they mean by undocumented is unsupported. That you can't call them up and say, hey, this doesn't work the way you described it here, or this breaks, or it crashes my system. If it's really undocumented, you can't call them up and complain. But if it says in Books Online it works this way and it doesn't, it's a bug, either a product bug or a Books Online bug. Or if it's in a knowledge base article, that's considered documented, and there is some level of responsibility to at least respond to questions about a feature in a knowledge base article or in a white paper published by Microsoft. So the Books Online is not the only source of official documentation, and when I talk about undocumented, I really mean unsupported and not guaranteed. That it could change certainly in the next version, but it might even change in the next service pack. So there's no counting on undocumented behavior working anytime you change the underlying software. So I'm going to be the first category of undocumented features we'll be looking at is trace flags and DBCC commands. Now, there are some documented trace flags. If you look in Books Online, there are a list of about half a dozen of them. Well, if you go out and search the net and look for SQL Server undocumented or just SQL Server trace flags, you'll find a whole lot more than half a dozen. And most of those are the ones considered undocumented. And then DBCC, I'll say a few specific things about in a little bit. But right now, what I want to do is just differentiate these two categories. A lot of people lump them together. We have trace flags and DBCC commands as the secret stuff we need to learn. Trace flags are numbers. You turn them on, and they're a toggle, so they stay on. You turn on this trace flag. There's a switch. It stays on, and what it does once you turn it on is it changes SQL Server's behavior. Sometimes just a little bit, sometimes a lot. So it's really not recommended that you start guessing. Oh, let's see what this number does. Oh, what happens if I put in that number? Or if you're not even absolutely sure, if you have a tendency to a little dyslexia. Not that anybody I know has ever done anything like this, but just transposing 2 digits in a trace flag. Why isn't this working? And then I go and look, and it's a completely different trace flag that I've turned on, and oops, what have I been doing to the system here? So be really, really careful. Some trace flags were added, or in fact, I think a lot of them were added to the product during the development cycle and were actually added for the developer's own purposes to test the work that they were doing. They wanted to make sure that a feature performed correctly, so they had a trace flag to enable different aspects of it or to simulate some kind of behavior that you might actually be invoking in real life out in the wild. But in the lab, they had to just sort of simulate it with a trace flag. Some of the trace flags were for their own testing purposes during development. Most of these were removed when the product went RTM, but not all. Also, another place trace flags pop up is for hot fixes. When Microsoft comes out with a hot fix, they don't come out with one hot fix for every customer that calls and says, this is the showstopper and we need a fix as soon as possible. They'll roll half a dozen fixes into the same build and give it to anybody who reports any of these bugs. But hot fixes are not tested anywhere nearly as much as regular service packs. So if you call up Microsoft and you've got a show-stopping bug and they agree that they will fix it and they give you a bill that has your fix and 5 other fixes, you might want to think twice before letting the other people's fixes in when you weren't experiencing that problem. So they give everybody a trace flag. To turn on your fix, turn on this trace flag. To turn on your fix, turn on this trace flag. And there's a trace flag for each of the major fixes added to the build, and it's recommended you only turn on the one for the problem you were encountering. And then in the next service pack, usually all those fixes are rolled in, so the trace flags become irrelevant, but a lot of times they stick around in the product and are not even needed anymore. But I'll show you a few that still do things for us. DVCC commands, again, usually talked about in the same breath, in conjunction with trace flags, but they're really very, very different animals. DBCC commands are text, and there's a lot of documented DBCC commands. They're not toggles. You run the DBCC command, and it, in general, just prints out some sort of a report, gives you information, and then when it's done, it's done. And there's no history of the fact that, oh, you ran this DVCC command yesterday. Of course, unless you traced it, then you've got a history. But you run a DVCC command to get some information, and that's the end of the story. And for DBCC commands, guessing, if you don't remember the exact spelling of the command name or the name of the command itself or the parameters, it's usually not going to break anything to make a guess if you can't remember the exact syntax. Unlike the trace flags, which I strongly recommend you never guess on, the DBCC commands are a little bit different. Trace flags are enabled using a DBCC command, which is why they are usually talked about together. There's this symbiotic relationship between trace flags and DBCC. DBCC trace on is what we use to turn on a trace flag, and as of SQL 2005, trace flags can be either local or global. To specify a global trace flag, we add the extra parameter -1 to the trace on command, and that means every connection will have that trace flag enabled. And I'm going to show you a demo of this in just a minute. There's also another DBCC command related to trace flags to show you the status. What trace flags have you turned on? That's nice to know, and that's how you might detect that you did have that transposition of digits and somebody was dyslexic out there. What is this one doing on? You can tell with the trace status. I'll show you that in the demo in just a minute. And I have been asked numerous times by the powers that be at Microsoft, especially the support services, to make sure you're always aware that undocumented means unsupported. They asked me specifically to put this bullet point in here. Undocumented means there is no support and it may change, and you guys all know this, so you won't be too upset if it breaks things. Nick, how nice to see you again. No, if you turn, okay, the question is, if you set it with the -1, is that going to survive over restarts, instance restarts? No, I skipped over that middle line in there. Starting a trace flag with a -1 is just while your instance is running. When it stops, it's off. If you want a trace flag to be on every single time you start up your SQL Server, you can add it to the command line if you start SQL Server from the command line, or using the configuration manager, going to the advanced tab, there is an entry for startup parameters, and you can add a trace flag as a startup parameter. I don't think we're going to have time to actually look at that, but you'd have to do it as part of the startup parameters to get it to always be there. So let's just take a quick look here at enabling trace flags and what the difference between local and global is. And all the scripts will be available on my website. There is a link to conference content, but I will also give you the direct URL at the end. So trace flags. So here we have, before we start, let's look and see if any trace flags are enabled. And I do have 2 global trace flags that I have set as parameters in my configuration manager. These are the trace flags to track down deadlock information. So I have those running all the time, and that's 1204 and 1222. So those are on in this connection, but I'm going to turn on another one for this connection, which I will tell you about in just a little bit. Trace on 3604, and I do not have the second parameter of -1. Notice -1 means one thing for DBCC trace status, and it means something else for trace on. A -1 would mean start it in every connection. Turning it on doesn't give any interesting output, but now when I look at trace status, I see that 3604 is on, and notice here we have these 2 columns, global and local. It says session for local. 3604 is just for this session. The other 2 are global. So if I went to another connection over here and looked at my trace status, it would not show that one I just set in the other connection because that was local. But if I turn this on globally, it's now set, well here, I've set it both locally and globally, and if I went to another connection, it's now set in this connection as well because I've set it as a global trace flag. So just while we're on the subject of trace flags, I'll show you another specific one that may or may not become useful. This is one of the most innocuous. 3604 is pretty innocuous. That's not going to really break anything. And 2528 is also pretty innocuous. Let me show you what it does. You may, and this is sort of like another area where we've got symbiosis between DBCCs and trace flags, and I haven't specifically talked about the undocumented DVCCs yet. We will shortly. But what not undocumented, in fact documented, is the fact that there is a DVCC help command that will give you syntax information about DVCC commands. DVCC help and then the name of the DVCC command will give me the syntax, all the possible parameters here, unless we say DBCC help for an undocumented DBCC command like DBCC Page. It says there is no help available, but you know what? It's lying. What about DBCC help for foo? Again, no help for foo. But if we turn on trace 2588, what this does is give help output for undocumented DBCC commands. So I can see the parameters for DBCC Page. It doesn't explain them very well. In fact, doesn't explain them at all, but at least it tells you what the possible parameters are. And DBCC help for foo, fooled you. There is no DBCC foo command, so no help is available for that. That's this one. It's not lying about. There is no command and no help. And then I can turn it off when I'm done. And now another trace flag, just to give you a little extra bonus here, is a trace flag which will print information in the error log every time a checkpoint runs. So I want this to be in every connection because checkpoints can happen all over the place. And now when I look at trace status, there I see my 3502 is on. So let me look over here in my error log, and it's under SQL Server logs. If I zoom in, you can see it there. Under Management, SQL Server logs, and my current log is the one that just started when I started my SQL Server instance a few minutes ago. And you can actually see it records every time you turn a trace flag off or on. It goes into the error log, and there's no other trace flag to control this behavior. This gets audited whether you want to or not. You'll have a record of all the trace flags that have been enabled or disabled. And so you can see the ones I was just exploring, and here's the one that I just most recently turned on, 3502. I'll keep that live. Use a sample database that I use for a lot of my tuning exercises, and run a checkpoint. Now when I go back and look at the error log again and do a refresh, what I see is it tells me in what database, not the name, just the number. You'll have to do the translation. What database had a checkpoint performed. And another trace flag that sort of enhances that output, I'll show you in just a minute, but in order for checkpoint to actually be an interesting command, I have to have dirtied up some pages. So I'll do some work out here in my credit database. I'll update a column called charge amount. I'll first reduce it by 20% and then increase it by 20%. So it's writing a lot of pages out. And then the trace flag, very similar to 3502, it's 3504, and you'll have these all in the scripts. I've turned this one on, and then when I run a checkpoint and look in my error log again, refresh, what it tells me is information about how the average throughput, the number of pages written out when cache was flushed for this database. Now, this is not a session in memory management or cache analysis. This is just, hey, look, see, isn't this cool? Let's move right along. Another day, we'll look into that. So I mentioned a couple of times already that we have this relationship between trace flags and DBCC. We need a DBCC command to turn on trace flags, but it works the other way as well. We need a trace flag to enable. No, we have a trace flag. Yes, we use DBCC to enable trace flags, and we have a trace flag to enable certain DBCC commands. In particular, the command DBCC Page, which prints out the actual contents of one of your data pages, will not print anything out to your client screen unless you have turned on trace flag 3604. That's one that I demonstrated in the demo, but I didn't explain what it did. Now I'm telling you. You need 3604 on in order for DBCC Page to give you any output. Not every single undocumented DBCC command needs 3604. DBCC Page does, and I know there's a couple of others, but I never even remember what they are because I just always turn it on. Anytime I'm going to be poking around the storage structures, I turn on 3604 just so I'm covered. So DBCC in general is used for a lot of different purposes. The original acronym, DVCC, used to stand for something, which it doesn't stand for anymore. It used to stand for database consistency checking, or checker, or check, whatever. But if you go and look it up in the books online as of 2005 or 2008, just look up DBCC. It gives a different expansion for that acronym. It no longer says consistency checker because DBC is used for so much more, and they finally realized, oh, wait, it's not just for consistency checking anymore. It's for whatever other quick and dirty tools they want to throw into the product. I'll tell you what it really means in just a minute, but initially, when Microsoft first got the access to port SQL Server to Windows, when they got that right from Sybase, they were not given the right to actually change the language at all. They were not really given the right to do anything other than port. They could not change the language that SQL Server used, but they were allowed to add new troubleshooting utilities. So initially in 6.5, when they were first trying to make it their own product, when Microsoft wanted to separate themselves from Sybase, they really couldn't add new features to the real SQL language, select, insert, update, delete, and new data types. Nothing like that was possible, but they could add new DVCC commands. So for a couple of versions, any new thing they wanted to add, which was apart from standard SQL, became a DVCC command. They just sort of went overboard with that. And that's how it really got beyond just doing consistency checking, and they just sort of stayed in that mold for several versions. They're now sort of rewinding. They're now saying, oh, wait a minute, we really don't need DBCC to do that anymore because the metadata experience is becoming so much richer. For example, there used to be a DBCC command to do your index defragmentation. That's now a part of alter index. There used to be a DBCC command to give you a fragmentation report, and that is now a dynamic management object, DB index physical stats. The old ones, DBCC index defrag, DBCC show config, they're still around, but they have not been enhanced to give you any new information about stuff that's now available in 2005 or 2008. They're there. They work like they did in 2000, but it's recommended that you use the non-DBCC tools going forward. But there still are a lot of DBCC commands that are not consistency checking. So DBCC now stands for, and I just imagine that they had this meeting where everybody was tossing out ideas like, what could DBCC stand for? Let's see. And I wish I was like, a fly on the wall, and I could have heard what the other rejected suggestions were. But what they came up with was, you can look it up, database console command. That is what DBCC stands for now. And if that's on the quiz, now you know. So how do I know all this stuff? Well, There's a story after I wrote my first book, after I wrote Inside SQL 7, I think it was a past conference or maybe it was Tech Ed, but somebody came up to me and said, Kaylin, how did you learn all this stuff that you put in the book? And I thought, what is he really asking here? And I said, are you asking how you could really learn all this stuff? And he goes, yeah, I want to know how I can find out all this stuff. And I said, well, read my book. But I'll tell you, in SQL 7, I was really, really lucky. I was contracted by Microsoft to actually write a course for support services. SQL 7 was such a dramatic departure from earlier versions. The whole entire engine was gutted and rebuilt, and I was contracted to write a 5-day course for support engineers on the way that everything in SQL 7 worked. So I was actually paid for all the research I put into at least the first book that I wrote. All the upgrades, I had to do those on my own. But so I had full access to all the engineers because I was actually working on something for support services, and they were just wonderful. I felt very, very lucky and was able to learn a whole lot and got a real foot in the door that way. Actually, I had feet in the door already because I did work for support myself for Sybase, and that's really where I got a lot of my start. But I don't want to spend a lot of time there. If you want to, where I found out some of my stuff is on the list here, but if for you to find out, make sure you add my books and stuff to this list too. This is how I know what I know to put on my blog and in my books, but you can add my book to this list, and at the very end in the big list, of course, I put my book there too. Ken Henderson was real instrumental with a lot of undocumented commands. In fact, his first 2 Guru's Guide books, Guru's Guide to Transact SQL and Guru's Guide to SQL Server Store Procedures, XML and HTML, have chapters just listing all the undocumented features in them. Those 2 books were written before he went to work for Microsoft. Then he wrote a Guru's Guide to SQL Server Internals and Architecture, and you would assume that would have even more juicy internal secrets. But he was working for Microsoft by that point, and he took out all those chapters. So, before Microsoft, he told you all the secrets. After, he didn't. So, I've actually been living away from home for the last many months as I was researching this, and I wanted to look and see all the stuff that Ken was saying. So I actually bought another copy of his Guru's Guide to SQL Server Stored Procedures, and I have one back home still. So I don't want to carry this one back with me. So I'm going to give this one away. This will be a drawing item at the end of the session today. It is complete with the CD in the back, although the CD has been used. I did copy it to my hard drive, but it's still there. It can be. It's not time bombed. It can be or limited use. It can be copied to your hard drive if you are the winner. So don't let me forget that. And then I'm just actually here showing you how to find all the Microsoft team blogs. There's some really, really good bloggers on the SQL Server team writing the product, as well as a partial list of the MVP blogs you can see over there. There's yours, Brad, right there. You see it? Brad's there, I'm there, Kim's there. Lots of people have blogs that you can find really juicy stuff on, and then the team blogs from the people who write the product. There's some really good stuff out there, so make sure you track those down. So let me show you a couple of DVCC usage examples. And I'm going to just show you the 2 commands that I use most often as I explore storage structures. I will show you DVCC Page first and show you a couple of things that DBCC Page might come in handy for, the kinds of explorations that you might be able to, or the questions you might be able to answer from using this command for yourself. Now, I'm not documenting these right here. I do talk about them in my book. And actually, DBCC Page sort of gets into a gray area, documented or not, because it is mentioned a couple of times in knowledge base articles. There isn't a knowledge base article that says, here's DBCC Page, but there are a couple that say you might want to look at a page and find out if something exists. So are they documenting it or not? I haven't asked them explicitly, so, who knows? Gray area. I want to use DBCC Page to look at a page from a table in my pubs database called authors. It's a little tiny table. There are only 23 rows in authors. And you can see the author's ID is a social security number. We have last names, first names, phone numbers, addresses, state, zip code. And if I turn on 3604, I can then use DBCC Page. And real quickly, I do want to explain what the 4 different possible options at the end are. The 4 parameters, as you really quickly saw in the 10 seconds I had the output up on the screen. The first parameter is the database name. Second parameter is the file number. Third parameter is the page number. And then there's an option 0 through 3, 4 different options. So option 0 just gives me header information, the page header. And I'm not going to look at anything except here, slot count is 23. Technically, they usually call rows slots on the page. That's all I'm going to show you here. It's just header information, no actual data. There's the end of the DBCC output, no data. But if I look at format 1, I get the same header information, and then look at that. I get data. Each row comes back individually. Looks really cryptic. Oh my gosh, how useful is this? We'll scroll to the right. And SQL Server is attempting to be helpful and translates any data that's character data into readable characters. Excuse me. So this is the first row, and you can guess what some of these columns are. You can see the phone number, the state, the zip code, there's the social security number, there's a last name, first name, address. Anything that's ... here is either non-character data or it's row overhead. It's not char, varchar, something in the row that is not automatically translated. And each row comes back individually. So there's a row, there's a row, there's a row. Each one, slot 6, slot 7, slot 8. This can be differentiated from format 2, which gives me the data, but it basically just gives me a page dump. All 8,000 bytes are just dumped out, all scrunched together here. Wow. And then down near the end of the page, it's like all a bunch of meaningless stuff. But all 8,000 bytes are here, and if we scroll over and look at the beginning part of the page, it still does the translation here. But it's just all scrunched together as a page dump. And then format 3 looks very much like format 1. The header information, and then the data. Each row comes back individually. Slot 0. But then after, here it is, sorry. Slot 0. And then there's the bytes on the row. Following each row, each column is listed separately. Now, sometimes when people look at this, they think, oh, this is really cool. This is all the information I might ever want to know. But I usually find this is too much information. I don't need every single column. Usually I just want to know how many rows are on the page or which rows are on the page. And sometimes, usually in fact, just by looking at a few of the columns in the row, in the translation over on the right, that's usually enough. Usually I don't want the value for every single column on every single row. If I really do want all the data, that's what my select star is for. I just want to see what's on a page here, and I don't need all the details. But there are some times where looking at the details can be useful, and we're going to come back a little bit later and see DVCC Page where the full information is more useful. Now, one of the things that you can use DBCC Page for is to prove to yourself or to others who might not believe it that when you have a clustered index on a table, it doesn't actually mean the data is in physical order. It's in logical order. It can be very easily accessed in order of the clustered index, but it is not stored physically in that order. And by actually doing a page dump, you can prove that. So if I do my format 1, my clustered index in my authors table is on the author ID social security number column. So if I start looking at my rows over here, here's my data. Scroll to the right so I can see it. Well, there's a social security number, 172 something, 213. Oh, wow. Wait a minute. These are looking like they're in order. Oops. Did I lie? Could someone prove to you that this meant they're actually stored in order? 341. We're going up. 409. Oh, my gosh. What does this mean? Well, maybe it's just coincidence here. Well, maybe not. Actually, what this is again, SQL Server just trying to be friendly. Because if I look up here, it shows you the offset of the row. Offset hex 631 is not up near the top of the page. I'll tell you that. I'm not going to translate 631. But if we go and look at the next row, B8, I'll tell you, is less than 631. So the second value in order is actually higher up on the page. And the next row is at 110, which is greater than B8. The next one is at 522, which is greater than 110. But then 374 is lower. We're jumping all over the place. 7FF. And oh, way down here, we have 60. And I'll tell you that's offset 96, which is the first location after the header. We're jumping all over the place here. And in fact, the way to know how SQL Server knows how to get to the rows in order is at the end of the page there's something called an offset array, and it gives the offset location of the rows in order. 1585 is the translation for 631 hex. That's where the first row in order is. 184 is the second row in order. 272, and you can see these are not sequential on the page. But if we did the page dump version and just looked at exactly what was on the page, the story's a little bit different. First, I do see my 96-byte header, which I can ignore. And then the first row is 409. The next row is 213. The next row is 238. And you can see now the physical ordering on the page. The actual ordering in the bytes of the page is not clustered index order. So looking at the page dump here shows you that. Now a question some of you might have had looking at this is, well, how did I know to look at page 177? There's actually 3 different ways I'm going to show you to get page numbers. This one I just happen to know because I've been using the Pubs database for 25 years. But it hasn't always been that page, though, let me tell you. I will show you right now one of the ways to find out page numbers, and that is another DVCC command called DBCC End. DBCC End takes a database name, a table name, and then an argument, which we won't be able to explain right now, and gives me one row of output for every row, every page of the table, whether it's a data page, an index page, or a special allocation page. This is a tiny little table with only 23 rows in it. Why are there 4 pages? Well, only one of them is page type data page. And, dun, 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 I don't have drum rolls, I have to do it myself. Page 177. That's actually how I got that number. The one data page is 177. Page type 2 is an index page, and I could look at the index. It's a non-clustered index. The clustered index is the table itself here. The non-clustered index is a different page, and then this page type 10 is an allocation page, which is beyond our scope this afternoon to look at. So there's the little tiny pubs table. So it's real easy to see what I've got. But what if it's a bigger table? In my AdventureWorks database, I have a table called Sales Order Header. Actually, I have a bigger one called Sales Order Detail. And it returns 2,000 rows. This is going to be quite awkward to go through and find all the data pages or all the pages that belong to a particular index. I've got index ID number is over here somewhere. Index ID. And I've got several different indexes, 2 and 3 and 9. So what are the pages how many pages belong to this index? How many data pages are there? The first page would be the one that didn't have a prev page. How do I go through 2,000 rows and find which page has the particular qualities I'm interested in, as the particular attributes? Well, look at this output. Isn't this like beautifully tabular? Wouldn't it be nice if I could just do a DBCC with a where clause? Give me the DBCC rows where page type equals 1. That would be so cool, but I can't do it with DBCC end with a where clause. But because the output is tabular, what I can do is put it into a table. I can create a table with all this information in it, and all I have to do is build a table that has the right columns. It's not rocket science, not like that optimizer stuff we saw this morning. This is just create table, list all the columns, and you guys don't even have to do it because you're going to have my script here. So I have a table. The only funny thing here is, what did I call this table? Oh my gosh. SP underscore. Where do you usually see that? Well, I am putting this in master. Look at that. But you usually see SP underscore for system stored procedures. So some people, no names, some people think that SP means system procedure. Some people think it means stored procedure and give all their own stored procedures the SP underscore prefix. Don't do that. SP actually means special. And it's not just for stored procedures. You can create all kinds of objects that are special objects. And what's special? Well, what's special about your system stored procedures? They exist in master, but you can access them from anywhere. You can do this with all kinds of different objects, including this table of mine called SP Pages. If I create it in master, I can then access it from anywhere. I can switch to my credit database and do a truncate of the table. I can switch to AdventureWorks and do a select. There's nothing in it yet. I can insert in, and then the other thing I didn't quite get into, but I need to talk even faster now, is you hopefully are aware that you can do an insert into an existing table with a nested exec that doesn't have to be exec stored procedure. It can be exec any SQL statement in parentheses there, including DBCC end. So this is how I can populate my table, and I'm going to go to a completely different database. I have a database called Northwind, and I will insert, this is a fuller example where I was actually grabbing table IDs and database IDs as variables. I could do that here and put my 4 little rows and then switch to a different database back to credit and still look at this SP page, and there's the 4 rows that I showed you before. They're now stored in a table. So I could do the same thing with a bigger output from AdventureWorks, truncate the table, and then insert the DBCC end from AdventureWorks from sales order header or sales order detail. And there's my 2167 rows in a real table. Not just looking like a table, but in a table. So now I can add my where clause. One example I'll show you here. How many pages of each type? 1234 data pages, 929 index pages, and 4 of these mystery number 10, which are an allocation type of page. There's a few other things in the script that we're not going to take time for here. So there's actually another DBCC page example I will be showing you just a little bit later, plus lots and lots of other DVCC commands. And in fact, there was something I was trying to check up on just today in my preparation, or just to make sure I had all my ducks in a row for this afternoon. And I discovered a document out there which was a list of DBCC commands. This I just found using well, did I use Bing or Google? Maybe I won't tell you. One of those things. A search. I just searched. I did an online search, and I found this list, new DBCC commands, undocumented new commands. This is not completely accurate. In fact, it does mention one that it says is undocumented, but is not really. DBCC mem usage memory status is listed. Oh, you don't see the header anymore. It's listed as an undocumented command, but it really isn't, because there is a very, very complete knowledge base article about DBCC memory status, which gives you pages and pages and pages of documentation about memory status. So it's not in books online, but there is a KB article for that one. I use that one a lot. Some of these I just was looking at this afternoon, and I couldn't get them to work, or couldn't figure out what they were doing. So no documentation. This is like Ken Henderson's book. What he does is he just lists them. Oh, look at this. Oh, look at this. With no explanation, no caveats, no, these are the situations where this might prove useful. He just lists them and says, do with them what you will. So you don't have to be as careful with DBCC commands as trace flags, remember, but be careful anyway. And that, I will have that document as in the file with all the scripts in case you want to see it, but you could go out and just do your searching all night long if you wanted. All right, what other category of undocumented or minimally documented information can we look at here? There's some stored procedures and functions I want to point out to you. Now, it's very interesting about the system objects, because we may not have documentation in the books online about certain stored procedures or functions, but because they're actual database objects, other database objects point them out. There is a view called sys.all objects, and if we select from sys.all objects, it shows you everything that's stored out there, whether it's documented or not. So just taking a look at that. Ooh, I never heard of that one. Oh, I wonder what that one does. I learned a lot just by looking at the list of available objects. For example, there's a whole lot of stored procedures that start with SP_MS that are not listed in the alphabetical list of stored procedures available to you. Most of the SP_MS stored procedures actually were created to support the tools. They are the stored procedures that Management Studio runs behind the scenes. When you click a button here, behind the scenes, it will go out and call one of these SP_MS procedures to get the information to populate whatever dialog you're working with in Management Studio. And one way you can find out what gets called when you do this or that is to set up a trace. A lot of what I learned is just by tracing Management Studio. Oh, what happens when I click this? What happens when I click that? And I've got a trace running to show me. And you can see a lot of the SP_MS procedures when you trace your actual interaction with Management Studio. In addition, all of your views, functions, and stored procedures can have a definition, which is a SQL statement, and you can look at the definition. Prior to 2005, we had SP help text. That's still around, but we also have a function called object definition. You can look at the definition of any stored procedure, function, or view all of the management views, all of the metadata views have a definition that you can look at. Sometimes it won't be very helpful, but sometimes it will be. And a lot of what I know, I learned just by looking at definitions of objects. I'll show you an example of that in the next demo. There are some really secret commands, some functions that start with fin_phys to actually show you physical location information. I will show you one example of that. And there are some procedures and functions which have, which themselves are not completely undocumented, but that have undocumented parameters. So I have a couple of examples of those to show you. And again, how do I know these things? I mentioned the tracing of the management studio, looking at object definitions. I read a lot of the SQL Server team blogs, and Paul Randall, on his blog, he has a whole category called undocumented commands. So a lot of cool stuff. One of the things I'm about to show you, I learned from Paul's blog. So let's look at a couple of those. I'm sorry? Is that what you're all doing here? Well, but see, Paul doesn't work for Microsoft anymore, so he doesn't care. I mean, and in fact, I mean, Paul's a wonderful guy, right? We all love Paul. But a lot of what he knows because he used to work on the storage engine team. And as the years go by and the product changes more and more, his inside connection is going to get a little more tenuous, a little weaker. I mean, he still knows all the people, right? But some stuff will just not be accessible to him anymore. So he writes great stuff, and I learn a lot from him, but it'll be interesting to see how much undocumented stuff he's able to keep blogging about as the years go by. All right, so let's look at undocumented procedures and functions. We're going to replace the battery here. Testing, testing. Oh my gosh. All right, let's give Andrew a hand. He was great. All right, so how can I find out what the objects are that might be interesting to me? I can look in at sys.allObjects. Here's all the ones that start with sp_ms, and there's a whole big long list of them. Some of them, or a lot of them actually, have to do with all the replication stuff. But there's others that don't have anything to do with replication. Here's one that might be interesting. MSDB user access. I'm actually going to show you what that looks like in just a minute. Some that a lot of people are familiar with are ones that actually cycle through, cursor through lists of databases or lists of objects for each DB, for each table, for each worker. So those occasionally might be useful. I'm going to come back to the other one in a minute, but let's look at this MSDB user access. And if I looked at the definition of it, which I'm not going to take time for now, but you can go and do whenever is convenient for you, I can pass in an argument of database, and for the current user, it will tell me all of the databases that I have access to. Well, look at that. Huh? I'm SA here. So I have access to all of my databases here. But if I pretend to be Joe and look at MSDB user access, Joe is not quite so privileged. He has access to only a few of my databases. And I'm going to go back to, well, DBO here, but actually also SA. Another procedure, I just want to mention this because I remembered this one as I was developing this session, and this one is one that used to be talked about a lot in discussions of undocumented procedures, especially people that wanted to write their own stored procedures or SP_objects of any flavor. If you want it to also be able to access the local metadata from wherever you happen to be, you used to have to use this procedure called SP mark system object. However, if I take a look at SP for anything with mark in the name, I don't see MS mark system object here. So at first I thought it had gone away. Oh, well, you know, it was nice while it lasted, but we're told we can't count on anything. But then I found some old scripts that I'd been working on years ago, versions ago, and it actually, even though there isn't anything in sys.allObjects with this name, it is actually out there. If I look at the definition, there is a definition for this. So what is the mechanism? It does warn us for internal use only, and says do not document, but there's other things out there that say that. There's other things that say do not document that you can actually see when you select from sys.allObjects. I have not yet figured out why this one is different. There is a procedure called MS mark system object, but it does not show up in all objects. I don't know why yet. I've got homework to do. No, sysObjects is a subset of all objects. All objects is, the old sysObjects? There is, okay, the old sysObjects is not a table. It's also a view. It's a compatibility view. Let's look at where name like mark here. The old sysObjects. I don't see it there either. So I don't know what the mechanism is, that it's there, but it doesn't show up using any of the metadata exploratory tools. So there's even more secret stuff out there that you might just stumble across without using any of the techniques I'm pointing out to you here. So we have the object definition. One of the things that I learned from object definition was that there are some undocumented parameters to some of the functions that I use. What I love or used a lot the old sysindexes table. This is not a table anymore as of 2005. It is a compatibility view, but one of the columns in sysindexes is a column called key count. How many columns make up the index? And especially when I was like exploring things like uniqueifiers, if you went to Connor's earlier presentation, not the one today, but the one yesterday, he talked about uniqueifiers. To be able to see that that was counted as a key column was a very interesting thing to do and could help you know what columns were counted as part of an index key. But the old sysindexes had it, but the new sys.indexes doesn't. Sys.partitions, sys.allocation units, none of the documented metadata for looking at storage and definitions of your objects has a key count value. But, hey, I'm on 2008. Sysindexes gets this value from somewhere. Where does sysindexes get it from? Right here, that it's showing it to me there. I had to look at the definition of sysindexes. And I want to put this in text mode so I can see it. And what we see when we look at the definition of sysindexes, not sys.indexes, sys.sysindexes, if we want to give the full name, but it comes up with a lot of its values by calling the function called index property. Now, index property is a documented function. Now, let me scroll back to the left and find that key count. There it is. Key count is actually derived by calling index property with an argument called key count 80. 80 is the internal number for SQL 2000, which was before we got all this cool new metadata. And index property is documented, but key count 80 is not. It is not listed in the list of information about each index, but it's there. And there are other undocumented arguments to some of the system functions that you can find just by going and looking at the object definitions here. So looking at object definition for the compatibility view gave me some information that I hadn't had otherwise. Now, what about another one where you don't have time to talk about today, but a lot of, the scuttlebutt is that there's a way out there to read your transaction log. There is a function called fndb log, and last year I think I gave a pre-con on the transaction log, and we didn't go into this in detail. I think Paul does give some information on his blog about it. But, hey, we can see the definition of objects. So let's look and see how fndb log gets the information that it returns. And isn't this useful? Not. So sometimes looking at the definition can be really helpful and other times not. Other times it calls other internal functions that you then try to look at and they do something that you can't even do on your own. So I'm not making any guarantees. I'm just giving you a couple of pointers of things you might want to try out. One more thing before we look at the page number, and that is something that I was unaware of for a long time. It's not really undocumented. Actually, I think in SQL 2005 it might have been. How many have ever used Profiler to define a trace, point and click, and then create a script from that definition? Oh, it's my favorite thing to do. You should not run production traces using the Profiler GUI. You should run production traces just using stored procedures, but creating those stored procedures is a nightmare. Using the GUI to point and click, I want to capture this, I want to capture that, and then the tool, the Profiler, will automatically script it out for you and give you something that looks very much like this. And if you look at the sptrace_create, it looks like there's only 4 parameters. There's the trace ID. No, there's 5 parameters. Trace ID is an output parameter. There's a number, which is what property you want to set, the file name, the max file size, and the final one here is the stop time. And in 2005, that's all they documented. And it's all most people are familiar with because it's what you get when you automatically generate a trace. It turns out there's another parameter to sptrace_create that doesn't show up here because you can't set it using the GUI at all. If you look at in books online for sptrace_create, the final parameter is the ability to set a maximum number of rollover files. If you start a trace through the Profiler graphical interface, you can't set a maximum number. You either say, I want rollover or I don't, and if you allow rollover, you can eat up your entire hard disk, sometimes really quickly. But if you run the trace through as a server-side trace, creating it with this stored procedure here, you can specify a final parameter, a max file size, and the max number of files to actually set an upper limit of how much disk space you're going to end up using. And this is one of those things that I actually refer to as minimally documented because it's not obvious, and a lot of people that I've talked to have not been aware of that. And one other function then is a second way to find out page numbers. If you want to use DBCC Page, how can you figure out page numbers? Well, there is a really, really cryptically named function called fnphyslock formatter. And Paul actually blogged about how he discovered this. Probably he was on something because the parameter, I don't know how anybody would guess to specify a parameter like this one here. %physlock, %%. And if you don't get it just right, you don't get anything back. But if I call this function exactly as I've written it here, along with whatever columns from a table I'm interested in, for every single row, oops, I need to be in the right database. It doesn't read my mind. Oops, and I want this in grid format. It will actually show me for every row file number, page number, and slot number. Ooh. So I don't have to use DVCC end unless I want to. So some of the other minimally documented information will be next, and that is SQL Server's own metadata. This is primarily documented, but there is a whole lot of really juicy stuff in here that is not obviously there. You need to spend some time poking around the metadata here. A lot of the information in the dynamic management objects, in fact, is stuff that was formerly undocumented prior to 2005 when the metadata revolution happened. All these sys.dm underscores are not real tables. They don't map to real tables. They actually just show us system information in a tabular format. To make it really nice, we can use where clause. We can pick and choose which columns we want. We can join one dynamic management object to another and do anything tabular we want, but they're really not tables. They don't even map to real storage under the covers. There's some really cool stuff out here. A lot of the DMOS are really, really cryptic, and even though there's good information there, the documentation is minimal. It's there, but it's minimal. But feel free to start poking around. Some of the other sessions this week actually gave you some queries using some of this metadata here. And there's a very small set of dynamic management views which start with the words system internals. And I'm going to show you an example. I did not change my slide because as the last session of the conference, it's a little bit too late to add one more thing to my list of where to get other information, and that is to go to the cool sessions at PASS. One of the examples I'm just about to show you is one that I got from a session earlier this week, something I just had not ever looked at before. Not that it's undocumented, but it was very, very hidden, and I didn't know that was out there. So I will be showing you that in the demo in just a minute. And so this is the slide that I should have updated. Sessions at PASS. I could put that in now because you can go buy the DVDs, right? And you can go look at all the stuff that you missed. So PASS sessions are a wonderful place to find out information that you might not have been aware of. And I'm so glad they're putting the keynote on the DVDs. I bought it this afternoon. I got to re-listen to that. So what kind of system information is out there, and how much time do we have to look at it? Oh, we've got some time here. All right. So let's look at system info. And one of the things I want to show you is going back to DBCC Page. Now, here I say the final column of it, but we got to hold off to see that in column format. Just a little bit more information is available in the DBCC Page in format 3 that I didn't point out to you earlier. So what I want to do here is first, this relates back to my pre-con, look at, generate a lock. I'm going to close down everything else here. Close all but this one. All right. So start a transaction, do an update, but don't commit it. And don't do this at home. This is for educational purposes only. You never begin a tran, do an update, and then stop and yak. You commit your transaction or you test things and you roll back. But here, I can do this. I'm the presenter here. So another connection will come along and try to select that row where title ID equals PC999, and it will block. And my users start complaining. How come nothing's getting done out here? So those people that took my session on Monday will know that they can go out and look in DMTran locks, and they can see who's blocking whom. They know they can ignore those locks, and what they want to look at is who is waiting for whom. Somebody is waiting for a shared lock on a particular resource, and here somebody has an exclusive lock on that same resource. Now, if the resource is a key lock, and that's what this is, and I certainly can't repeat my whole pre-con here, but a key lock is not just a lock on a key, it's a lock on a row of an index. A key lock just means an index row, but it doesn't give us the specific row. It just gives us a hashed value of all the key columns. There could be up to 900 bytes in index keys, so it's not going to print out all 900 bytes. It takes all the index columns and crunches them together with a hash formula and gives me something totally cryptic here, except the fact that these are the same value. I can see who's blocking whom. This one is blocking this one because they are contending for the same resource here. But what resource is that? Well, because this is such a small table and there's so little blocking going on, I can make a good guess that it's on page 197. This is a page lock. And for page locks, it does tell me the actual page number. It doesn't tell me the row, but it will tell me the page. So I can actually look at 197, and if I look with format 3, something I sort of skipped over before is for each of the rows, in addition to giving me, and now this is not the titles table anymore, I'm not the authors table, this is the titles table. In addition to giving me the value in every single column, the very last thing it returns is this value called the hash key. So if I know what page, I can do a search on this page. So go back here, and now it's a little bit cumbersome because this value here is actually really long. So what I usually do is I just first stick it in a notepad page, and then because it's got all that blank space, that's going to mess me up, and then just copy the good stuff. And then when I look at the DBCC page output, I can do a search for that value, and there it is, and scroll up to it's slot 12, it looks like, and we're getting close, we're getting close. This is the row with the title ID of PC9999, which is the row that we're trying to get to over here. So by looking for the hash key on the page output, you can find the actual row that's locked. Now, there's another way to get those hash keys. And for those of you that were in my session Monday, I didn't tell you this Monday because there's just so much information and I forgot about it. It's in my book, but I forgot to mention it when talking about locks all day on Monday. So it's another one of these percent values, except we don't have to use it with a function. We just use it all by itself with any row, and it returns the hash key for every single row that qualifies in our where clause. Now, for my little teeny titles table, this is no big deal. But if you look in the sys.tran locks and say, okay, that's the row that's locked, let me see what row that corresponds to in my production table with 47 gazillion rows in it, a query looking for one particular lock res value might take a long time. So this is not always the most efficient way to find a particular row. If you can narrow it down to the specific page and then use DBCC Page, in a lot of cases that's going to be a lot faster than doing this search across the entire table. Here it's a tiny table, so I can find the row real quickly. This is a 20-row table. But for a 2 zillion row table, it would take a lot longer to find a row that you're looking for. So it's possible that you can just use this at lock res value to find what corresponds to what key values that are locked, or you might first need to find the page and then drill into the page and look for the specific value there. I did want to show you one other thing here, and that I was looking at a page of a table. If I use format 3 for a page of a table, that's when I have to scroll all the way down to see my excuse me, to see my hash key. Where is it? key hash value. It's a little hard to find, but using format 3 for an index page is really, really cool. Right now, you'll just have to trust me. This is an index page. I know that because I did a DBCC ind looking for pages of page type 2, and I pulled this page out. And this is an index page, and index pages with format 3 actually return tabular results. And the very final column is the hash value. So if it's an index page, then it's even easier to use. But for a data page, format 3 still gives you the value. It's just a little more awkward to find. So how much time do we have left? We're just about to the end of the official time before. I know it's supposed to be a 90-minute session, but they say I'm supposed to leave time for questions. But I've got a couple of other things I'll show you. Some of the interesting individual metadata objects. You might find some interesting information. And there's a view called DM Exec Query Optimizer Info. If you've looked at any of the optimizer details, looked at any kind of a plan analysis session this week, if anybody talked about trivial plans, it can tell you how many trivial plans you have, how many tasks the optimizer has processed. I'm not going to be able to explain any of this. In fact, I forget what a lot of it means. I'd have to go back and read the optimizer chapter of my book, which I didn't write. Connor Cunningham wrote the optimizer chapter, so there is good stuff in there. He wrote the optimizer, and then he wrote the optimizer chapter. How about that? And then DMOS Schedulers has some really nice stuff in it, lots of cryptic stuff. But when I go and teach a class and I've got a machine set up for me as the instructor, they usually don't give me a spec sheet about how much memory and how many processors they've given me. I have to figure that out for myself. And usually one of the first things I run is looking at DMOS Schedulers to see how many schedulers there are. And visible online are my real CPUs that are available for different tasks. These might be hyper-threaded. They might be dual-core. This view doesn't tell me that, but it just tells me as far as SQL Server is concerned, there are 2 CPUs to be used. But some of the other information is like how many tasks are associated with each of your CPUs, how many of them are runnable, how many are waiting, how many are, what else? Some other cryptic information that we really certainly can't look at right now, but you might find some juicy stuff there. And then another view called DMOS Sysinfo sometimes takes people by surprise, the kind of stuff that's in here. How many CPUs? It's right there, a little easier to find. How about that? And a real common question that still shows up on the help forums is, how can I tell when my SQL Server was started? How do you tell when it was started? I used to use, there's something in sysprocess you can get, but yes, I would look at the create date for tempdb, but it's in this view here. SQL Server start time. Look at that. Except this isn't true because my laptop is still on East Coast time. But Eastern Standard Time was 1651 that my SQL Server instance was started. And then I do want to show you a couple of things from these system internals views. These are what I call minimally documented. If I go to my books online, and there is a page for system internal views. If I just go through my index and look at sys.system internals, they do not show up. They are not individually called out. Sys.system internals, there's a lot, I do need to spell correctly if I have any hope. System internals. And over here, there's a bunch of things that start with system, but there's nothing that starts with system internals in the alphabetical list. But there is a page in Books Online called System Internal Views, and it mentions these 3, and that's all it tells me. That's all it says. There are these 3 views. Do with them what you will. Actually, no, it doesn't even say that. It says these are reserved for Microsoft internal use only, but too bad. We can select from them. And this is one, I'm going to show you two examples here. One is an example that I just learned from Connor earlier this week when he was talking about uniqueifiers. If you create a non-unique clustered index, and I'll come back to the previous example in a minute, he created a table with a non-unique clustered index. There it is, create clustered index. If you don't say unique, it's not unique. Create a table, a clustered index, and a non-clustered index. The clustered index, because it's not unique, SQL Server needs a way to tell every row apart from every other row. Every row in a clustered index has to be unique one way or another, and if you don't make it unique, SQL Server adds an extra hidden column, but it's not hidden from us anymore because we can do DVCC Page. And if you do DBCC Page, you will see those uniqueifier values. Every time you have a duplication of a value, SQL Server will add an incremental value to it. So if you have a clustered index on last name, which is probably not unique in any population of any size, the first Smith, well, that's unique. It's the first one, but the next Smith will get the value 1, then Smith 2, then Smith 3. And looking at DBCC Page, you can actually see those counters going up. But if you want to know whether you got a uniqueifier or not, I used to just look at the row key count value. That's one of the reasons I was interested in looking at key count, because that uniqueifier counts as a key column. But this script Connor showed us was even more explicit than looking at key count. And in the view called System Internals Partition column, there is a column called isUniqueifier. What this view does when I join it with sys.partitions is show me every index column for every index. So I have the table is called NUCI. This was Connor's name. I just copied it from his demo. NUCI, there are two indexes, the clustered index and the non-clustered index. The clustered index has 3 index columns, and column 0 is a uniqueifier. Column 1 and 2 are not, but the non-clustered index also has 3 columns, even though I just built it on a single column, because non-clustered indexes always include the clustered keys, and in this case, it includes the uniqueifier. So the two clustered index, or the clustered index column 1 here, why are there 2 columns? Oh, no. All right, I give up. Why are there 2 columns? That's what it looks like. Because actually, I did change Connor's demo a little bit, because he had everything be an int, but I made one of them a small int, one of them a tiny int, so we could tell the difference here. So yes, thank you very much. The 4 bytes is for that uniqueifier. The small int is the 2 bytes, and the tiny int is the 1 byte. So all the columns in the table are showing up here. But for the non-clustered index, all I get is the tiny int column, which is called 2. But then I have added on automatically the 2 clustered index columns, which were the small int on column 1 and the uniqueifier. Just as an aside here, the fact that the uniqueifier is for a 4-byte integer, Connor explained that even though if we had an unsigned integer, we could have up to 4 billion bytes, it's actually treated as a signed value. We can only go up to 2 billion, which means there actually is an upper limit on the number of duplicates of the same value you can have, and that is not documented. It is not documented anywhere where it talks about creating indexes that you can only have 2 billion and change duplicates of the same value. So be careful. All right. There is a specific error message. I don't remember what it was because I don't think I've ever tested it, but sometimes when I talk about this in class, oh, it did come, the error message came up?
Yeah, because he had a message when we were changing an index on it, but we were trying to change the table.
Oh, okay. So there is a very specific error for exceeding the 2 billion rows, but you can look it up yourself or try it out yourself. It did say something about unifier. All right. All right. Let's. I think there's a couple of other things in here that we're not going to take time for, but you'll have the scripts available. The final checklist here. My book has all this information and more in it, and Ken's book has a lot. Ken's 3 SQL Server Guru's Guide books have lots and lots of juicy internal information as well. The knowledge base is full of information that hopefully you can find useful. Books Online has stuff that I'm still discovering. Oh, I didn't know that was there. Looking at the definitions of your metadata can show you things that you were unaware of. The blogs, in particular, Paul and Kim have some really great stuff on their blog, as well as the SQL team, SQLblog.com. There are dozens of bloggers out there with great stuff. And then just doing a search. Oh, SQL Server traceflag. Yeah, it'll return a lot of pages of stuff, but there's some gems in there that just might prove to be something useful for you. So my goal here was just to show you not only some of my favorite undocumented features, but point you in the direction where you can go and discover more on your own, and maybe you'll find something that really, really proves useful for the work that you're doing. We do ask you, even though this is our last session, to fill out the evaluation form. It will be really useful for PASS and for myself, and the drawing will still be based on these evaluations as well as any others that you turn in today. So I want to thank you for coming, and I haven't forgotten the book, so thank you. And this is how we're going to do it. We're going to look at birthdays. I have a random number generator out here. I have a random number. Oh, didn't mean to do that, but that's all right. I'll open up a new management studio here. I'm going to generate a random number, which is a number between 1 and 12 for the month. And then based on the value I get back, I may change that 31. And those of you that have studied statistics know that actually you can prove that there easily could be overlap, especially in a room this size. We might even have 365 people here with a good chance of some duplication. But if it turns out we've got duplication, I have a duplicate prize. Not 2 of the book, but I've got another prize as well. So get ready. And somebody could roll the drum. I'm not going to this time. Month is 11. November. How many of the Novembers do we got? Do you have his driver's license with you? All right. November has how many days? 30 days, half November. And here we go. 4th. Any November 4ths in here? Oh my gosh, what are the chances of that? Should we do some statistical? 30th. November 30th. Only one? All right, we've got a winner. Thank you very much. And I hope you had a good week.